All right. Hello, my name is Jaxson Jerger.
I'm Consalvo.
I'm Joe Gross.
I'm Fariha Faramandi.
And that's Ruo Chen over here. He's getting prepared. We are Gator Tracks. We're working with the Utmost form factor body tracker. It stands for line line of sight form factor tracker. Essentially, it's going to track your body movements and into a virtual space. And this is our post-motor presentation. I'm going to go ahead and run in it.
Our user interface is lightweight and minimalistic, allowing users to be intuitive with it. The device tab is where all devices, power devices are listed, with the representing body parts where you attach them. The device settings is where you control and input your body measurements, calibrate trackers, input Wi-Fi data. And the data set tab is mostly for information where you have the rotational and positional data.
And then for the hardware state, we've got 6 ESP32s that are all dev kits, 2.1.1 boards, equipped with MPU 6050 IMU breakout boards as well. They're all contained within the same chassis here, and then we have them all sending 100 Hz updates over UDP across our router over there, which is over on that table, and then it goes to the server on the PC here, and then we also have a little light fixture on the dev kit boards that is able to blink and tell us whether or not the Wi-Fi is connected, or rather the trackers are connected to the Wi-Fi. And then regarding cases, we took rigorous testing into making sure that any strenuous pulling forces will not break these side connectors, which allow little loops of polypropylene webbing and allow for also stretchiness of elastic polyester combined with some hook and loop Velcro, quote unquote, and to bind it to the other side. And with this design, it's extremely modulable. We're able to swap these connectors out at will, and essentially they've been well tested.
All right, so what did our team do well? I thought our team was very good at finding solutions. So for example, when our PCB boards didn't work out, we were quick to find a dev board that could do the same thing. We also fully 3D printed the cases, and that allowed for modular design and easy repair and replacement in case parts broke. We also use the devices and data screens to inform the user of the tracker status. For instance, we use the onboard LED to inform of the network connectivity status. And we also limited the user complexity after initial setup. So all the users had to do was walk through a few initial steps, and then they were good to go. We also excelled at task assignment. So we actually had the addition of another teammate halfway through production. We were quick to redistribute tasks for an effective project. There was also frequent task overlap that required collaboration, but our teammates were quick to do so. And then we utilized Discord for open communication, and everybody was always available and prompt to reply. We also took joint action on a lot of tasks. So each of the teammates helped solve issues outside of their assigned tasks, even if it meant going above and beyond to learn new skills. And timelines were quickly modified to accommodate any project issues or changes that arose. And then we also frequently redistribute tasks to help meet any assignment deadlines.
As with any project, and as with any project, there's always a lot of failures that occur, so we had a lot of overlapping issues, so team members had to constantly talk to one another and communicate. They also had to make sure that there weren't any merge conflicts, which happened a lot of times. We did have a hard time dividing up hardware, software, and firmware elements into significant tasks. So with all of us working together, it was a little difficult. And then we did run into dependency issues because of our product we were using, specifically for our product that we created. We also had hardware and a lack of resources issues. So we didn't have much PCB design experience, which caused our transitional boards to the operational ones a little difficult. We also had a lack of resources, so at first it seemed like OpenVR had a lot of information, but once we started going into the detail, we realized it wasn't as much as we wanted. So it did limit us, and also the silicon shortage also caused us to have resilience parts as well.
All right, we're going to move on to the demo. We got it. Okay, so as you can see, the trackers are connected on micro USB cable. They're powered by external sources, and when they first start up, which you probably saw me doing, they have to start face down. This is so the IEU calibrates correctly. Let me switch to sleep. Okay. Okay, so as you can see, since we are on 2.4 gigahertz Wi-Fi, since it is Wi-Fi dependent, it is highly dependent on Wi-Fi. But as you can see, the orientation is completely out of sync. So I need to calculate it. Now the calibration is dependent on the orientation of the headset. So once the calibration completes, you can see that the orientation has been corrected. And you can see that as my feet move, my body in virtual space is also moving.
30 seconds.
Okay. Now, if I have a different type of body, what I can also do is input my measurements into this form here. And when I save the measurements, it also updates the skeleton in real time in VR, allowing it to adapt to a wide range of body types.
10 seconds.
You can also see the data being submitted by the trackers. And that's pretty much it.
Awesome.
Thank you.
Audience members.
Yeah, if you get some questions or if anyone has them.
Have you guys tried going to like the website?
We are doing yes. But that was going to take too long to put up for me.
Yeah.
We're probably not 30 seconds.
Like your
But
phone time.
yeah,
Oh,
yes. Pretty fun.
So I just want to say, I know Karsten knows how much effort you guys have put into this, and I know the challenges behind it. I think it's really cool what you managed to pull together. So I think you should be proud of your work.
Yeah. Can I ask you a quick question?
Sure.
So I have an Oculus, and I would like to use your system. Like, I saw you started up, like you did some like yarn start thing. Like, how far is this from being able to like deliver to somebody like me?
Okay, so we were trying to convert it into an executable, but so far that we have dependencies issues between all of our platforms. So only the UI is able to be an executable right now. That doesn't work with our server that handles all of the communication with the tracker.
Okay.
So we're in process, or we're trying to.
Cool. Cool. Well, keep me in touch because I want to try it on
We're
my
ironing out those
system.
details right now. We also want to design custom music using these things to make sure they work with the batteries, so they don't have to. Sure. Yeah. But obviously, the wireless portion of it is that we have it will go to
Yeah,
our
the
router
data,
on this
yeah.
end. Sure. It is highly dependent on Wi-Fi though.
Yeah.
I noticed that on 2.8 gigahertz it doesn't perform pretty poorly.
Yeah.
If the computer is on the 5 gigahertz network, it does perform a lot better because it's not overnight.
Yeah, it's cool. Awesome. Well, thank you very much. All right.